Welcome all to the video on particle size reduction, comminution of solids, preferably crushers and grinders. I am Dr. G. Kirtiga, Associate Professor of Chemical Engineering, SRMISD. So, to discuss the mechanism of size reduction, there are four types of mechanism in which the size reduction happens. First is impact, where the size reduction happens by sudden impact of blows. Example, hammer mill and pin mill. Next is by attrition. Attrition is by rubbing or shearing action between the particle, the size reduction happens. Example, ball mill, rod mill and colloid mill. Third is by compression. By compressive forces are applied to the particles for size reduction. Example, jaw crusher, gyratory crusher and roll crusher. The third one is compact, where size reduction happens by pressing the material between two surfaces to form flakes and then it is broken down. Example, roll crusher and compactor. So these are the four important mechanisms by which the size reduction happens. Coming to the types of size reduction equipments like crushers, what is the feed to be fed in and what is the size of the product which you can expect. Example, crushers, you have to feed large pieces of the solids and it will be broken into small lumps. It is classified as primary crusher and secondary crusher. In the primary crusher, very large lumps of like mine material or the recovery material will be added and it will be crushed to a product of 150 to 250 mm. In secondary crusher, it takes the product of the primary crusher and gives a product size of 6 mm. Grinders. So grinders crush the feed to the powder. So here the input is from the crusher and it makes it to a powder form. There are two types of grinders. One is intermediate grinders and the other one is fine grinders. Here again the particle size of the product varies. The third one is ultra fine grinders where it takes feed of less than 6 mm and gives a products in micrometer range. Third is cutters, they cut the particles of uniform size and shape of 2 to 10 mm length you can expect in these cutters. Classification of size reduction equipment. So again, based on the four mechanism of size reduction, the equipments has been classified as crushers, which helps in getting coarse and fine particles. Basically, it acts by compression. Examples include jaw crusher, gyratory crusher, and crushing rolls. Next is grinders of intermediate and fine particle is a product which you can get from it. It occurs by impact and attrition. So we will see grinders in detail, the classification of grinders. Third one is ultra fine grinders where it happens by attrition. Example, hammer mill, agitated mill, fluid energy mill. Fourth is cutting machine. Example, dicers and sliders. Coming to grinders, there are four different grinders and intermediate particle size reduction instruments. Example, hammers, rolling compression mills, revolving and tumbling mills, and attrition mills. This rolling and compression mills is further divided as bowl mills and rolling mills. And tumbling mills are divided as rod mills, ball mills, pebble mills, and tube mills. So in our video, we will be discussing about a few size reduction equipments such as ball mills and gyratory crushers. Here, coming to the crushers, crushers are slow speed machine for coarse reduction of large quantities of solids. So they operate by compression. They can break large lump of hard materials. They find application in rockery and mining industries. So as we saw earlier, jaw crusher belongs to the crusher. It is further classified as blade jaw crusher and dog jaw crusher. It is there is second classification is gyratory crusher and smooth roll crusher. Coming to jaw crusher, here you can see jaw crusher works by compressing the feed between a stationary and a movable jaw. So it is divided as blade jaw and doggle jaw crusher. In blade jaw crusher, the movable jaw, the second movable jaw, is pivoted at the top so that the maximum movement occurs at the bottom. You can see here using a flywheel, the top portion is being held and so the bottom portion freely moves out along with the stationary surface. In doggle jaw crusher, the movable jaw is fixed at the bottom and the free movement or the maximum movement occurs at the top. So this is the primary difference between the blade jaw crusher and doggle jaw crusher. Again, seeing in detail the working of a jaw crusher. Example, blade jaw crusher, we know it works by a principle of compression. Here you can see the feed enters, the feed is crushed and it moves as a product. Here you have a flywheel, have a fixed jaw, and this is a movable jaw. So the movable jaw is pivoted at the top by using eccentric shaft. And you have a pitman and toggle, and also you have a reversible jaw liners. So here this discusses the equipment, fixed jaw and movable jaw, and there is a swinging jaw. This is a swinging jaw. So you can see this is a swinging jaw. The swinging jaw reciprocates in a horizontal plane and makes an angle of 20 to 30 degree with the vertical fixed jaw. So that they are made up of manganese steel to withstand abrasion. The faces are all made of rough so that it helps in crushing the particles. So this eccentric shaft causes vertical oscillation of the pitman, which is communicated horizontally to the movable jaw by toggles. So here the vertical oscillation is converted into horizontal motion by this pitman and toggle. The speed of rotation should not be high as the fines cannot escape. Coming to the, you can see the working here, and this is a eccentric motion of the eccentric which is placed in the top along with the flywheel. So the material is caught between the upper jaw and it is crushed into smaller size as the material moves forward by compression. The crushed material falls into the narrow space during the backward motion and it is recrushed. The crushed material drops out from the bottom. Jaw opens and closes at 250 to 400 times per minute. The maximum movement of the jaw is at the discharge because it is pivoted at the top, right? So the maximum movement will be at the discharge and it is less choking. Here, the flywheel may choke if you are putting uneven load on as a feed. The next type of crusher is gyratory crusher. It also works by compression. Here we can see a funnel shaped casing open at the top. The conical crushing head gyrates inside the casing. So this crushing head is mounted on a heavy shaft provided at the top. Upper end of the shaft is held by the flexible bearing and the lower end of the shaft is driven by an eccentric to trace circle. The speed of the crushing head is 1.25 to 425 gyrations per minute. Here we can see the schematic diagram of a gyratory crusher and the working of the gyratory crusher in the next slide. So you can see there is a conical casing and the feed is fed at the top and there is the outside heads are stationary. Only the inside, the center portion of the casing moves. So the bottom of the crushing head moves towards and away from the stationary wall. So these are the stationary wall and the movable thing is held by a casing and a shaft. The solids are caught in the V shape between the head and the casing and are broken and rebroken. The crushed material drops from the side to of the bottom. The crushing head of both top and the bottom do crushing. So it is continuous. So it is continuous action, uniform load on the motor, less maintenance and power consumption, high capital cost suited for large scale applications. Grinders are used to subdivide the solids to a finer product than crushing. So it takes the feed from the crusher and gives it as a powder form. Example, hammer mill and impactor, revolving mill, tube mill or ball mill. Here coming to hammer mill, it works by the principle of impact and attrition. It has high speed motor mounted on the shaft, usually on horizontal like with an inside cylindrical casing, and you have a swing or hammers which is pinned to this rotor disc. Hammers or rectangular metal bars with plain, enlarged or sharpened edges which moves along with the rotor when it rotates at a certain speed. The product falls through the gyrated or screen to the lower portion, and many rotor disc rotates with a diameter of 150 to 450 mm, carrying 4 to 8 hammers in a single shot. So this is a outer casing. This is a screen through which the product is taken out, and you have hammer with a rotor at the center. So let us see the working of a hammer mill. So here we can see the shaft is rotated at a high speed. Shaft is rotated at a high speed and hammers swung out radially by the centrifugal force. The material is beaten several times by the hammer against the braking plates or against the screen, which causes impact and attrition. So it can help in size reduction of steel turnings, bark, leather, hard rock or sticky clay. But the thing is, large current of air produced makes the environment dusty because it let out all the small particles as the powder, which is the product which is collected from the bottom. This is a view of a hammer mill. We have previously seen you have a screen from which the product is taken out. You have a feed, you have a rotor with the hammers attached, and the different types of hammers are bar hammer, T-headed hammer, ring type hammer plane, and ring type hammer toothed. So this is a solid rectangular hammer which strikes uh, in the casing. The intermediate hammer mills produces up to a product size of 20 mesh, and fine hammer mills can give you less than 200 mesh product size. Next, coming to revolving or doubling mills. So it has a cylindrical shell rotating on a horizontal axis. It is charged with the grinding medium to half of its volume. So mostly steel will be the outer shell, and it is lined with an abrasion resistant materials like manganese, steel, ceramic, rubber inside the cylinder. Operation can be batched or continuous. Some of the classification of the doubling mills are ball mill, where L is equal to D, length is equal to diameter of the cross section. It works by impact, and it has steel bars, rubber or wood balls. Tube mill, where length is twice or length is greater than 2D. It also works by impact. It has smaller balls and gives finer product. Rod mill, it works by rolling compression and attrition. It has steel rods. Pebble mill, it has ceramic pebbles. It works by impact. Let us see ball mill in detail. So this is a ball mill construction or a schematic of a ball mill. So it works by impact. A hollow cylindrical shell, horizontal or slightly inclined, rotate at a very low speed using a drive gear of 60 to 100 rpm. Here, length is equal to diameter of the mill. Inner lining, there is an abrasion resistant coatings of magnesium, steel or rubber. It is partially filled with balls made up of stainless steel or rubber. There is a core screen at the outlet in order to prevent the escape of balls. The balls occupy 30 to 50% of the mill volume, and the diameter of the ball varies from 12 to 125 mm. You can find out the optimum ball diameter required for the ball mill by getting square root of feed size. It can be operated in batch mode. If you close and just take the product at the end, it is batch mode. It can be continuous mode where the feed can enter the ball mill continuously and product can be taken out in a continuous manner. If you have very large ball mill, it will be of 3 meter in diameter and 4.25 meter in length. So you can see the working of a ball mill. The thick balls, small rounds or balls, the steel balls or the rubber balls, and the small ones are the one which has to be crushed. So here for continuous operation, you have to feed at a 60-degree cone and product has to be taken at 30-degree cone to the right. Ball rises and then drop on the feed. Solids are grounded and reduced in size by impact. When the shell rotates, large balls segregates at the feed end and small balls near the product end. Initial breaking or the initial size reduction happens by large ball drops at the largest distance, and small particles by small balls from a short distance. Again, coming to the working of ball mill in batch operation, as I said, in a batch operation, the outlet is closed and the inlet is also closed, and it rotates like quite some amount of time is given for the size reduction, and the mill is stopped and the product is taken out. In a wet grinding, see, it can also be operated in a wet manner where you can add some liquids like water to ensure the paste form. So you have to do it at lower speed. It gives you lower consumption of power, higher capacity, dust reduction, but you need to get the products dried once you take it from the ball mill, and also you have a high wear on the grinding medium. So these are the consideration which we have to take during wet grinding in a ball mill. Coming to the advantages of ball mill, it is low installation cost, low power requirement. It can be suited for any degree of hardness. It can be operated in batch and continuous mode. It can have a closed and open circuit grinding. Even explosive materials can be operated in an inert atmosphere in a batch mode, and the grinding medium is cheap. Application, it finds application in coal, pigments, feldspar for potteries. Action in tumbling mills, like action in ball mills, there is something called critical speed, which is the minimum speed at which the centrifuging action happens. So at the critical speed, the centrifugal force will be exactly balanced by the weight of the mill. So if we are operating near the critical speed, then we won't get fruitful product. So we have to operate 50 to 75% of the critical speed. This critical speed is NC. It can be computed from the formula 1 by 2 pi is equal to square root of G by capital R minus small r, where capital R is a radius of the ball mill, and small r is a radius of the steel ball which is placed inside the ball mill. So from which we will get the critical speed of the ball mill and hence the operating speed. So the references for this section is from MECAP, Unit Operations of Chemical Engineering, Coulson, Volume 2, Chemical Engineering, Introduction to Chemical Engineering, and NPTEL course. Thank you for watching.